Okay, so we're going to have a bit of a revision look at Venn diagrams and two-way tables. So these are ways you can use to help organize outcomes from experiments or theoretical probability into different categories, which can help us find a bit more information about it. So we've got an example here that shows the type of computers owned by 100 people. Okay, so that's the total group that we're working with. And this information has been drawn into a Venn diagram and a two-way table, which you can see there. Now, the 100 comes in because that is the total. So we can see the 100 here for the two-way table. That's easy to find. But in the Venn diagram, you add all the numbers to get to 100. So that's how you can check that you've got the right amount in there when you're finished, get to 100. So we need 100 in both. So these diagrams both show that 12 people owned both a Mac and a PC. And in a Venn diagram, it's where they cross over. And in the two-way table, it's this first box here. Mac, PC, both of those are owned. Then we've got 62 people own a PC. Now in the Venn diagram, that is found by it's everything that's in this circle on the right-hand side. That is going to be 50 plus 12, which of course adds to 62. And in the two-way table, it's the total column of column of the PC row. So 62 people own a PC. Now some of those also own a Mac, but that's not asking anything about the Mac. It's only asking about the PC at this time. Then we've got 57 people do not own a Mac. Now, in the Venn diagram, this is found. I'm just going to see if I can change the color of my pen. So 57 people do not own a Mac. So it's all of the ones that are only in the PC section, so not part of the Mac circle, plus it says 7 outside which don't own either a Mac or a PC. So that is the 50, which is PC only, plus the 7 that is there. And in the two-way table, that is the no Mac column that we're working with here, the total of that column. Now we can also use this to easily work out probability. So we know that probability is either theoretical or experimental, is number of favorable outcomes. So whatever we want to happen over total outcomes or total trials is the terminology generally used in experimental probability. So the probability of getting a Mac means we've got 43 people who own a Mac. I'm just going to change my color pen one more time. Green this time. 43 people that own a Mac, and that's found by all of the people in the Mac circle. So 31 plus 12 is 43. Or again, we can go straight to the Mac column. So 43 people who own a Mac out of 100 people in total that the information's come from. The probability of only owning a Mac is just the part of the circle that doesn't have any link to the PC section. So that's 31. And in the two-way table, it's Mac only, no PC. 31 out of 100. The probability of getting a Mac or a PC, well, you can find this in two ways. So 93 out of 100 is the answer that's listed there, but it's probably just as easy to find 1 minus the probability of owning no computer. No computer. Remember the complement that we've talked about before? So it's 1 minus 7 out of 100, which is 93 out of 100. Or of course you could add everything up, but that's probably the quickest way. And the probability of the Mac or the PC is where they all mix, where they all combine. So that is 12 out of 100, and of course that should be simplified down as far as possible, 3 over 25. Okay, hopefully that all makes sense. Now I want to have a look at doing an example. So from 50 desserts served at a restaurant one evening, 25 were served with ice cream, 21 were served with cream, and 5 were served with both cream and ice cream. And the first thing we're asked to do is illustrate the situation using a two-way table and a Venn diagram. So we're going to do that in both ways. Now I'm just going to set it up. So obviously I'm going to do my two-way table first, and I need some headings, and then I need my 2 rows, plus I need my totals. Now obviously you're going to use a ruler, so yours is going to be nice and straight. So I'm going to put the ice cream along the top. So with ice cream, without ice cream, totals, and then we've got with cream, without cream, oops, I'm in the wrong section, or with cream, without cream, totals again, because totals can be really helpful as they were before. Now let's start filling it in. So it's kind of best to start with what you got. So we've got 50 in total. So I'm going to put that down in the total column. So that's what we've got with cream or ice cream or nothing. We've got 50 desserts. Now it says 25 were served with ice cream. So our with ice cream column is this first column, and 25. So again, we can put the total in here. 25 were served with ice cream. Then we've also got 21 that were served with cream. So again, we can put the 21 in the row that's got with cream in it. Now the last one is 5 were served with both cream and ice cream. So that's going to go in this first box. Cream and with ice cream. And what we can do is work out what we're working with from here. So if we've got a 25 total in our first column and 5 already, so this has got to be 20. Again, on our first row, if we've got 21 in the total and 5 with ice cream, 16 must have been without ice cream. If we've got 21 in our first row and our total's 50, there must be 29 here. There must be 9 here, and of course that should add to 25. So that's what you should have there. So just fill in what you've got and then calculate the rest as needed. Now let's do a Venn diagram. Of course, you're going to use a ruler for the outside box. Make sure you put an outside box in it because it helps define the area we're working with. So again, let's work with what we've got. Now, this time I'm actually going to start with where they intersect, so both cream and ice cream, and we've got 5 that have both cream and ice cream. We also know 25 were served with ice cream, so in this circle on the right we're going to have 25 in total, but in the section that's only ice cream is going to be 25 minus 5 or 20. So don't be afraid to do those calculations there. Similarly, on the circle on the left hand side, 21 were with cream, 5 were with ice cream as well, so we've got 16 there, and we need to put outside of our box how many got nothing, and that was 9. So you can see we've got the same information in both the two-way table and the Venn diagram. It's just set up differently. All right, let's answer the rest. How many of the desserts did not have cream? So B. No cream. Well, we can read that off our tables, which would be our total here, no cream. Or you can read that off your Venn diagram, which would be the ice cream section only, and nothing. So 20 plus 9 or 29 would work from both of them. And then the next one is neither cream nor ice cream. So that means it's got nothing. So in this case, that's going to be what's outside of our circles or in this one here. Good. Oh. Okay, so let's go to C. Now we're going to look at some probabilities. So find the probability that a chosen dessert had cream. So one probability of cream is going to be all of those that had cream, whether they had cream or ice cream. So it's going to be 16 plus 5 or just straight to 21 out of 50. Remember, 50 is our total desserts. So the probability of getting one with cream is 21 out of 50. the probability that it was only cream, which is not the same as the one we just did. The one we just did had cream or cream and ice cream, but the probability of only cream this time is the one that had cream but no ice cream, 16 out of 50, which of course we could simplify down to 8 out of 25. And our third part had cream or ice cream. So the wording really matters here, cream or ice cream. Again, you could add up all of the things in the circles, or I'm going to take the complement, 1 minus the probability of neither cream nor ice cream. Now we found out how many that was before back in B. We'll turn that into a probability, 9 out of 50. So 41 out of 50 is the probability of that happening. Okay, thanks very much.